In lesson 8.2, we're solving two-step equations. We're starting by modeling first. So we're going to be solving these two-step equations first by using algebra tiles. Before we start using algebra tiles, I drew this key here for you so you would know what these pictures represented. The longer rectangles, if it has a plus sign in the middle, those are going to be your positive variables. And your longer rectangles, if it has a negative sign in the middle, are going to represent your negative variables. The squares with a little positive sign, those are your numbers, those are your positive numbers. So that would be, each square would be a positive 1. And then the squares with the negative sign, each square would represent a negative 1. So we're going to look at solving this equation right here, 3n plus 2 equals 11. And here are our algebra tiles. The rectangle represents like a mat. The middle line represents the equal sign. So this side of the equation is on this side of the mat. The equal sign is represented by this line. And then this side of the equation is the right side of your mat. So if I was going to solve 3n plus 2 equals 11, you could see that these three variables, they're positive, represent the 3, positive 3, n, plus 2, here's our two little positives, equals, there's our line, and on the other side, we have 11 positive little squares. Okay, my goal is to find out what one of these equals. It's the same thing as when you're solving an equation, your goal is to find out what the n equals. You want the n all by itself. So when you model the equation, you either use manipulatives, or you could get these, again, there's apps and there's interactive manipulatives, virtual manipulatives you can use, but I didn't want to have you go do that, so I went ahead and drew these and put them here for you. So the first thing we have to do is we want to get the n all by itself, okay? The first thing you want to do is always work with the number that is not next to your variable. So I'm concentrating on, I need to get rid of the 2. And remember, we solve this by using inverse operations. So what's the opposite of adding 2? I want to subtract 2. I want to take these 2 away. And so by the circling and the arrow, that's indicating that we're taking them away. Well, whatever we do to one side, we have to do to the other side because we have to keep this equation balanced. Okay, you could also think of an equation instead of a mat, you could think of it like a balanced scale. And if I want to keep both sides equal, whatever I do to one, I have to do to the other. All right, so now that I have taken off these 2, well, I would have 1, 2, 3 left on this side. And on this side, if I had 11 and I removed 2, well, now I only have 9. Well, if I want to know what one of the variables equals, and there's 3 of them, then I would have to divide these into 3 equal sets. So now that they're in 3 equal sets, you would know what one of them equals. One of the n's equals 1, 2, 3 positives. So the solution that this mat is showing, I want you guys to go ahead and write this in, would be n equals 3. All right, so you're going to be doing the same thing on the your turn. Again, I didn't want to have you go find this app, or I know you don't have models, so I started drawing these out for you. They're all positives here except for that one little negative 1 right here. So the dark squares are positives and all these variables are positives. So what you're going to do is you're going to do the same thing we did up here. What would you have to do to find out what one of these equals? Okay, you're solving these equations here, and then you're going to have to draw your result over here. Okay, so you're going to pause your video and try to solve your equation with your picture using your model. Pause your video. Okay. The first thing I want to do is I want to get these variables all by themselves. So that means I'm going to have to remove all of these numbers. If I remove them, you guys should have shown that you're taking them out, okay, with an arrow. Well, whatever I do to one side, I have to do to the other side. So how many did I remove? Well, I took away 5. So over here, I have to take away 5. I'm going to circle these last 5 over here and take these out. Well, then you have to think, well, what do I have left? I have 2, okay, and remember we're using this equation, so I have 2x, these represent our x's, 2x equals, on the other side, if I take 5 away, well, taking 5 from 11 leaves me 6. So that's what I have to draw over here. I have to draw what I have left. So I'm going to draw my rectangles here. And you don't have to shade them in. You could have put plus signs. And on the other side, you're going to draw 6 little squares. And because I know I have to divide these into equal sections, I'm drawing them this way instead of in vertical rows or columns. So if I have to divide these into 2 equal groups, then that means that each x would equal 3. So x is going to equal 3. That's our solution for this one. On the next one, well, this one was a little tricky, okay, because I have a -1. Well, what's the only way to get rid of a -1 if I want to get rid of it? That means I need this to go away, because all I want left on this side is my 3x, or I'm sorry, 3n. And the only way to get rid of a -1 is to give it a +1. Okay, so remember that a -1 and a +1 cancel each other out. So these two actually make 0. Okay, +1 and a -1 cancel each other out. Well, if I added a +1 to this side, I have to do the same thing to this side. So I'm going to add a little positive there. And remember, all of these darks are positive. Okay, so now I want to redraw what I have. And notice that I had 8 on this side. Okay, and I added 1, so now I have 9 on this side. Well, I want to redraw it so that I could divide it into equal groups. So again, here I'm going to draw my 3 positive ends. And on this side, I have to draw 9 positive little algebra tiles. These represent our numbers, so that's +9. So that means if I'm dividing it into equal groups, that means that each n, 1n, equals 3. So again, right here, n equals 3. In the next section, representing solutions on a number line, it says that you have used inverse operations to solve equations with one operation. You can use the same method to solve equations with more than one operation. After solving, you could represent the solution on a number line. So in example 2, it says Tony carried 5 identical baseball bats to a ball game inside a carrying case weighing 12 ounces. The combined weight of the bats and the case was 162 ounces. How much did each bat weigh? Then they want you to graph the solution on a number line. So in step 1, they're asking us to write an equation to represent the problem, and they want W to represent the weight of a bat in ounces. So if you think about the words, okay, 5 times the weight of each bat. Okay, so we're going to be multiplying 5 times W because that's the weight of each bat. And then we have to add, because it says plus 12 ounces. Okay, that was the weight of the carrying case up here. So plus 12 always indicates the equal sign. And then 162 ounces was the total weight. Okay, so if we want to use the inverse operations to solve this, okay, that's step 2, wants us to use inverse operations. This is how you're going to be solving 2-step equations, and we expect you to show all of your work and all of these steps. So I'm rewriting my equation over here. Okay, remember, whatever I write, you should be writing on your paper. So remember, my goal is to get the W by itself, and we always want to start with the number that is not the coefficient, not the one next to the variable, but the one that stands alone. So if this was a model, okay, my first step would be to get rid of this 12. So the opposite of adding 12 would be to subtract 12. Whatever I do to one side, well, I have to do it to the other. A positive 12 and a negative 12 cancel each other out because that would just make 0. So on this side of my mat, okay, or my scale, I would have just 5W left over here. And on this side, I actually have to perform this operation. So 162 minus 12 would leave me 150. And now we have multiplication. Okay, the 5 is next to the W. What's the opposite of multiplying times 5? Dividing by 5. Whatever I do to one side, I do to the other side. Because I have a 5 on top and a 5 on bottom, I can cross them out. So on this side of my equal sign, all I have left is W, and 150 divided by 5 is 30. So that is my solution, W equals 30. I like to box my answer. And then they want us to go ahead and graph, and notice that that dot is already there for us. And so go ahead and label that is your 30 on your number line. Okay, flip your notes over. On the back is the your turn, and you are going to show your work because you have to actually write your own equation, and you have to solve it, and you have to graph it. So you are writing, solving, and graphing each of these problems. Okay, you're going to have to show your work over here because there's really not much room, and then be sure you graph your final solution. Okay, so pause your video. He'll be watching you. Pause your video. Okay, so on number 6, it says Maureen wants to buy a $198 camera. She has $30 and plans to save $12 each week. In how many weeks will she be able to buy the camera? So $12 each week, I would do 12 times W, okay? And then it says she has 30 already. Okay, so that's her, what she starts with. She's trying to save $12 a week, and you're trying to figure out, well, how long is it going to take her to get a total of $198? So this is what I'm going to have to solve. So first I wrote it. Now I'm going to go solve it over here. 12W plus 30 equals 198. Well, we have to do the opposite. What's the opposite of adding 30? Would be subtracting 30. Whatever I do to one side, I do to the other side. Okay, so 12W equals 198 minus 30 would be 168. The opposite of multiplying times 12 would be dividing by 12, and you should be showing your division with a fraction bar. So 168 divided by 12, the 12 on top and the 12 on bottom cancel each other out, and so W is going to equal 14 weeks. So over here, I should have left room, but let's put it down here. W equals 14, and you should label, I'll abbreviate that to weeks. Now I have to graph it. So all you have to do to graph it is go plot that point right at the 14. Number 7 was talking about a rectangular picture frame. Okay, that has a perimeter of 58 inches. The height of the frame is 18 inches. What is the width of the frame? So perimeter, okay, an important word in that problem. You should remember the perimeter formula from 5th grade. Okay, so if not, you could have looked that up, but I'm drawing my picture frame, okay, because it says that the height is 18 inches. Okay, well, height is typically, the same as length. It's the longest side. You are looking for W, the width. That's what we're looking for. So if I go look up the perimeter formula, it's going to be 2 times the length plus 2 times the width. And remember, the length is really the same as my height. So the P stands for our perimeter. They already gave us the perimeter. It's 58. So I'm going to plug in and substitute the 58 where the P was. Okay, the 2 is next to, that's an L. okay? I should have made a cursive L. Okay, so the 2 is next to the L. The length is the same as my height again. So 2 times 18 plus 2 times W, because I don't know what W is. Well, if I go start to solve this, you know you have to multiply first, and 2 times 18 is 36 plus 2W. Okay, so here's my equation that I'm going to have to solve to find my W, to find my width. So that would actually be my first answer here. I'm going to put 58 equals 36 plus 2 times the width. That's one answer. This time I know I need more room, so I'm leaving some room here. Then I have to proceed to solving this, which means that I have to get rid of this 36. Well, it's being added to 2W. What's the opposite of adding 36? Subtracting 36. What I do to this side, I have to do to the other side. The positive 36 and the negative 36 cancel each other out, and 58 minus 36 would actually leave me 22. Okay, and then on this side, all I have left is 2W. Well, again, the 2 is next to the W, which means it's being multiplied. The opposite of multiplying times 2 is dividing by 2. Whatever I do to one side, I do to the other side. So W is going to equal 22 divided by 2. So W is going to equal 11 inches. So here's my second answer. W equals 11 inches. And then we have to go graph 11 inches, which notice that we have a 10 and a 12. Okay, it's counting in multiples of 2. So the 11 is going to be right in the middle of the 10 and the 12. And if you want to go ahead and label that there's your 11, you can. Okay, on the last section, we're going to be talking about determining if a given value makes an equation true. Okay, in order to determine if the value makes a true equation, you're trying to see if it's an actual solution. So you're going to have to substitute, okay, and then evaluate, find the value for, and see if you get what you should be getting. So, for example, in example 3, our problem says, after first doubling the weight being pulled by a dog sled, the sled driver removes 20 pounds. The final weight of the dog sled is 180 pounds. The equation 2W minus 20 equals 180 can be used to find W, which was the initial weight of the dog sled. Determine which, if any, which of these, if any, is a value, any of these values, which one is a solution to this equation. So in order to figure out which one of these, if any of them, are a solution, we're going to have to go substitute these values right where that W is. Okay, so first it wants me to just substitute them in. So if I substitute the W, I would be putting the 60 there. Minus 20 equals 180. That's my first one. In the second one, they want me to substitute an 80 where my W is. And in the third value, they want me to substitute a 100 where the W is. Okay, so that's the first step, is substituting instead of W. You're actually putting the values they're giving you. W equals 60, W equals 80, W equals 100. Well, in the next step, they want me to actually evaluate. That word evaluate means find the value to. So now I actually have to solve these. Well, I'm going to rewrite them down here. And when we are solving, remember that you have to follow the correct order of operations. So multiplication would come first. So if I go multiply 2 times 60, I'm going to get 120. 120 minus 20 would actually be 100. And does 100 equal 180? No. So you could just put those are not equal. So this would be not a true solution. I'm just going to put not true. Now I'm going to solve this one. So again, I'm rewriting it down here. And 2 times 80 is 160. 160 minus 20 is actually 140, and 140 does not equal 180, so this one is also not true. We're going to try this last one. Okay, so when I multiply first, 2 times 100 is 200. 200 minus 20 is 180. So does 180 equal 180? Yes, it checks out. This is the only one that is a true solution, okay, for this problem. So the result is that the initial weight of the sled was 100 pounds. That's our answer. Remember, the W represented the initial weight. Okay, so you're going to do the exact same thing we did here. You're going to be substituting values to see which given value is an actual solution to these problems. So I need you to pause your video one last time, and I need you to show all your work to see which one of those you get as a solution. Pause your video. Okay, on number 8, our equation 3k plus 15 equals 66. The first one I'm going to plug in or substitute for k is a negative 7 plus 15 equals 66. Okay, so notice we're working with some negative integers in our problems, so you're going to have to remember all these rules. So when you are multiplying a positive and a negative, okay, you get negative 21 plus 15 equals 66. When I have a negative plus a positive, remember you can't add them. We end up subtracting here, and so that would be actually be a negative 6, and negative 6 does not equal 66. So this one would not be a true solution. Okay, we're going to try the next one. So 3 times 17 plus 15 equals 66. Well, 3 times 17 is 51 plus 15. We're going to see if that equals 66, and yep, 66 does equal 66, so that one checks out. So this one is true. Well, obviously, if you already found the answer, you know that this one is not going to be it. But we're going to go ahead and check it because that's what you should be doing. Okay, you want to be 100% sure. So 3 times 27 is actually 81 plus 15 equals 66. So when I add these together, that's 96 does not equal 66. So this one is also not true. So my answer on the line, the only one that was a true solution, is k equals 17. That was the only value that was true. Now on number 9, remember the fraction bar means divided by. So I'm going to go plug in these values for p, and since I'm needing some room over here, I'm going to start up here. So the first one I'm going to plug in is my negative 72. Negative 72 divided by 9 minus 5 equals 7. Well, I have to do my division first, and negative divided by a positive is actually a negative 8 minus 5 equals 7. Well, when you have subtraction with integers, that's when you have to do keep it, change it, change it. So actually it's going to end up being a negative 8 plus a negative 5 equals 7. Well, that ends up being a negative 13 equals 7, and negative 13 does not equal 7. So this one is not true. Okay, the next one I'm going to do is I'm going to plug in an 18. 18 divided by 9 minus 5 equals 7. Well, 18 divided by 9 is 2 minus 5 equals 7. So again, I have subtraction, so keep it, change it, means it's going to be 2 plus a negative 5 equals 7, and 2 plus a negative 5 is actually negative 3, does not equal 7. So this one is also not true. So we're going to try this third one, and I'm going to go right here because I'm, again, running out of room. 108 divided by 9 minus 5 equals 7. Well, 108 divided by 9 I know is 12, And 12 minus 5, yep, is 7. So this one is our only true solution. So the value that is a solution, we're going to just write on the line that P has to equal 108. All right, we will be practicing more of this in class tomorrow. And if you have any questions, be sure to jot them down so you don't forget. See you tomorrow.